In the previous lecture from Jay, we assume that all measurements are made in AutoCAD with a final drawing set. This is an extremely accurate way of doing your QTO. It should absolutely be done when you near your final design in order to double check that your initial material estimates were good. Ramp wall and fill volume calculations are tricky to figure out geometrically, unlike tiers, which follow a more predictable pattern for scaling. Therefore, in this short lecture, I'll show you how to automate the process of calculating ramp wall and fill volume with trigonometry, which gives potential for optimization during the design process. First, let's explore method 1. Stating our assumptions, we will say that the ramp walls extend to the tiers on one side, which are each offset by 25 centimeters, and the back wall on the other, shown by the AutoCAD screenshot on the slide. The ramp fill will assume more of a trapezoidal shape. Now, for method 1, using the standard drawings, there are 4 possible cases. First, the ramp is angled and the 30 centimeter wall forms a triangle. This will happen if the ramp slope, sorry about that, is greater than 1 meter in this dimension. As we go 1 meter down, we form a triangle with that 30 centimeter wall. Now, depending on the further dimension, the 50 centimeter wall can also form a trapezoid in this way, or it could form more of a polygon shape, depending on what this dimension is. In the case where this dimension matches up exactly for the 50 centimeter wall, mind this is not to scale, I like to split the section and calculate the area in 2 parts. Small triangle in the beginning and a rectangle here, because this dimension for the base of the 30 centimeter triangle is already calculated. And we can find these dimensions because we know the distance from the center line to the back wall. And with this distance, we can calculate this angle and use that to find this angle. And with this angle, call it theta prime, we can use the 1 meter dimension to find this length here, the base of the 30 centimeter wall triangle. And with subtracting the distance from the center line, we can find this distance here, and using the equation for the area of a triangle, 1/2 base times height, and the area for a rectangle, base times height, we can find the areas of these triangles here. And in this case, the 70 centimeter wall is just going to fill in all of that area below. So that was just for cases 1 and 2, where the 30 centimeter wall definitely forms a triangle, and then the 50 centimeter wall in case 1 or 2 either forms a trapezoid, where it meets up exactly where the ramp slope hits the back wall, or it forms more of a polygon shape where it bridges the gap between where the ramp slope hits the back wall. But now let's explore case 3, and that's where we have the dimension on the ramp slope here that is less than 1 meter. And in this case, that 30 centimeter wall is going to form more of a trapezoid structure. That makes it easy for the 50 and 70 centimeter walls, because those will just fill in as rectangles. But this 30 centimeter wall, we need to then calculate it in 2 parts. And what I like to do is once again split it up into a triangle In a rectangle, we know this dimension because that'll be on the standard drawings, and whatever is left over here, we know this dimension as well because this total dimension is going to be 1 meter. And then we can use that center line to back wall distance to calculate the area of these two sections. And finally, case 4 would be our easiest case where the ramp slope is 0 degrees. So we basically just have a large rectangle and we go down 1 meter, 1 meter, 1, and whatever is left over in order to calculate the areas of these 3 sections. But note that, like I mentioned in the beginning of this lecture, the tower to center line, the tower center line would be here. And this would be the distance up to that edge of that back wall right here. But as we step down in tiers, that center line is going to start off as a 40 centimeter offset. But then each additional tier we step down is going to bring that 25 centimeters out. So depending on the number of tiers you have, you need to adjust these rectangles accordingly. And this will make more sense when you are consulting these standard drawings, but remember, these 25 centimeters can start to add up and make a difference in your amount of material you're using. So a conservative estimate would just be to assume this whole section, but as you want to refine that calculation and save material, you don't want to over order, we have that contingency factor built in to make up for that. We want to refine and sharpen the pencil on those calculations and see how much less material we're using as we step down in the tiers.